POW train sample. Gretchen rode on a passenger train for 570 miles between 9 a.m. and 6:30 p.m. to visit a friend in a different city. This formula you can use down in Part B. Distance traveled equals speed times time. In Part A, what is the average speed of the train? She is traveling miles through a certain number of hours, so we're going to do miles per hour to get her average speed here. So what we need to do is we find out that she's traveled 570 miles, but we know that she's been on the train from 9 a.m. to 6:30 p.m. So we need to figure out how much time has elapsed. So we go from 9 to 10, that's 1 hour, 10 to 11, 11 to 12, 12 to 1, 1 to 2, to 3, to 4, to 5, to 6, and then an extra half hour. So what that tells us is 1, 2, 3, 4, 5, 6, 7, 8, 9.5 hours have passed while she was on the train. So to get her average speed, you're going to take the miles that she's traveled, which is 570 miles, and divide by 9.5 hours. That gives you 60 miles per hour. So her average speed was 60 miles per hour. Gretchen, however, thought that the train was traveling at 76 miles per hour. She calculated her arrival time based on this speed. What time did she tell her friend that she would be arriving? So we know from the formula up above here that the distance traveled equals speed times time. So distance equals speed times time. We still know that she's still going to be traveling the 570 miles. However, in this case, her speed isn't 60. She assumed that it was going to be 76 times the time, which we don't know how many hours it was. So I'm going to use h. To get the h by itself, we have to divide by 76. 50 divided by 76 give you 7.5 equals h. So she told her friend that it was going to be 7.5 hours later. She's still left at 9 a.m. So 7.5 hours later, 10 o'clock, there's 2, 3, 4, 5, 6, there's 7 hours, would take us up to 4 o'clock, but we have an extra half an hour. So she told her friend that she would have arrived at 4:30 p.m.